why the Continua, why are we working on it this year, and why it's a significant part of your math classroom.
Number two, we want everyone that is attending today to be able to come away with a better understanding of how the Continua can help support both us as teachers and students move our learning forward.
And then finally, we want to develop a better understanding of how students are progressing towards proficiency. And we're not sure why that says 1, 1, 1. It's supposed to say 1, 2, 3.
Okay, to get us started, we're going to do a little activity that you can use in your classrooms as well. It's a fun way to get started and get our minds activated on today's thinking. And our activity today is called an SD mystery.
This SD mystery comes from Steve Wyborny, and we are going to list all the resources that we used for this presentation at the end. So if you're wondering about where we got anything, you'll just have to wait till then.
Okay. All right, to get us started, just maybe on a piece of paper or a whiteboard nearby, how many objects do you think are in this class?
We'll let you scramble around and find some materials for a second. Okay, can anyone give us a thumbs up when they think they're ready, just so we know that that was a good amount of time for you? Thanks, Aberrator. Okay, sweet. We're going to continue.
All right. In our mystery, clue number 1 is that the answer is a number that is less than 50. So if you have a number, if you need to revise your thinking or change what you wrote down initially, please go ahead and do so.
Okay, so clue number 2 is, what is clue number 2? The answer is an odd number. So you might have to revise your guesses again.
And clue number 3, the answer is a multiple of 3. For example, 3, 6, 9, 12.
Okay, ready for clue number 4? The answer includes 2 different digits.
And for your last clue today, clue number 5 is neither of the digits is a 2 or a 4. So using all of these clues and your estimation skills, you can correctly arrive at the solution.
Sorry, honest. So if you got 39.
We have a 37.
We have a 37. If you got 39, then you are right.
Ta-da! 39. So to consolidate sort of where the thinking was in this activity, what we would see in this activity is that students needed to be able to look at reasonableness. Often we see that students are very afraid to be wrong. So in this activity, we kind of scaffold it so that everybody has an entry point, and that the focus is really not on the answer, but on the reasonableness of your answer. So, for example, a student might say that I counted the ones that I can see and know that there have to be more than that.
You'll also notice that they have to, this is where their understanding of even and oddness comes out.
We're also going to be able to see skills from the Continua, examples like skip counting or using repeated addition in order to be able to generate those multiples.
And of course, it's very open-ended so that it's low floor, high ceiling, and everyone can at least jump in from the beginning.
And a key idea here is that everybody has an entry point, and not only that, a re-entry point. So as we progress and we give more clues, students have an opportunity to re-engage with the activity. So just a tool from Steve Wyborny that might be useful in your classroom.
And you can find that link at the end of our presentation today.
Okay, so we're going to get into sort of the nitty-gritty of what we are doing today. We thought we'd start by talking about the Focusing on Fundamentals document that came out in late August, early September last year from the government, talking about what are the fundamentals of math. And we talk about what the fundamentals of math are all the time. Everyone thinks they know what that is. Most people go to knowing their facts automatically, but actually in this document, they've broken it down into 5 key points, which we'll just go through really quickly with you.
Yeah. So the idea that we want students to be able to work with numbers. So what does that mean? We're looking at, can they read numbers? So for example, 5,565,100. How can they represent numbers? Because we want them to be able to have a sense of how much a number is. So for example, how many 100 blocks would it take to build 1,000, 10,000, 1 million? As well as being able to order numbers. For example, if you were comparing 23 and 32, which number is larger and how do you know, how can you justify that?
Also, when we talk about composing numbers, like yes, kids can compose numbers like 53 into 5 10s and 3 1s, but do they also know that's 2 26s or 10 5s and 3 1s? So it's different ways that they can break down numbers. I just wanted to check quickly, can everybody hear us okay? Okay, great, thank you. Hi, Brandy, thanks.
Thank you, guys.
Okay, so we're moving on to the next step of our focusing on fundamentals. The next thing is sort of recognizing and applying and understanding number properties.
So understanding how numbers behave in operations. So for example, if we're adding 2 even numbers, that our answer has to be even, or that 2 odd numbers will always result in an even sum, or that adding an even and an odd will always result in an odd sum.
Or that an odd number cannot be divided equally into 2 wholes.
Or when we see through skip counting, we're going to see, for example, we're counting by 4. So 0, 4, 8, 12, 16, 20. The digits in the ones column, when you're counting by 4s, will always be either 0, 4, 8, 2, and so on, if we are counting and starting from 0.
Okay, we're going to move on to the next one, which is the part where most of us think about the fundamentals, which is the mastering math facts and developing mental math strategies. For example, when you're adding like 3 plus 12, it's better to start at the higher number and add 12 plus 3. Or, sorry, like 5 plus 6 is like adding 5 and 5 and 1 more.
And ultimately, as a skill, what we want students to develop is the ability to work with numbers mentally and be able to do those calculations without the requirements of calculators or tools.
Okay, and then we get to developing proficiency with operations. And basically what this means is that we want kids to know what to do and when to do it. And we want them to do that with ease, precision, and consistency. And we want them to be able to explain what they're doing and be able to repeat it in a different problem or...
Yeah, so to expand on that is that when do students understand when to multiply, not just how to multiply, or when to divide, when to add, when to subtract.
Okay, so how do we get to this automatic thinking in math?
So one of the misconceptions that we're really sort of working to change is that that memorization is sort of the key to math success. Memorization works. It's fast, but it's very limited. So, for example, if a student knows 6 times 7 equals 42, that's great, but that's all they know. So when we're talking about automaticity, though, is not only is it still fast, but it's flexible. and that students also understand the relationships between the numbers. So in that same example, 6 times 7 equals 42, which a student also understands as 7 groups of 6. So using that, they can also figure out, well, 6 groups of 6 would be 42 minus 1 group of 6 to give us 36, or 1 group more from 42, which would give us 48.
I guess it just kind of gives kids a pathway to knowing that they can figure out their facts without just having to recall them. They can rely on one fact and then be able to solve other ones.
So from this just from that one fact of knowing 6 times 7, a student can solve a complex problem like 59 times 7, because 60 times 7, if 6 times 7 is 42, 60 times 7 is 420, and we subtract 1 group of 7 to give us 413. So really allowing students to work flexibly and solve. It's a strategy that has legs that students continue to use as they progress through all the grades.
Well said, team. We just thought we would share this example with you about the facts that students actually know.
So we often think that, students need to just keep practicing those multiplication tables and keep practicing and practicing. And really what we see, though, is that students are trying to memorize 100 individual facts that are not related at all. This example here shows us how little they actually need to know if they understand some of the relationships between the numbers. So in the top left-hand quadrant, you're going to see these are the facts that students know if they know their 2s, 5s, and 10s. To the right of that, we can commute so that they know that, so the idea that 2 times 0 is the same as 0 times 2. If we commute, we get those facts. And then if they know their 0s, 1s, and square numbers, so 2 times 2, 3 times 3, 4 times 4, if they know those and we commute, we get the grid that's on the right. So if you notice how few facts that students actually have to learn once they have those foundational facts in place.
Exactly.
And to sum up the fundamentals, we have a quote for you from Carol Lloyd. That is, in the end, the skills required to solve a complex problem. Break the problem down into smaller parts, approach it from different angles using different methods, not get intimidated or frustrated when the path isn't obvious. These are the practical skills in any field or endeavor, from astrophysics to parenting. Ideally, math prepares kids to be better thinkers no matter where they land.
This is a great quote that we use as adults all the time. You can even think of it as driving to Tim Hortons. If there's construction on the road, how do you go around that? How do you still get there? How do you do that in an efficient way without getting frustrated and looking at it in different ways?
How do we help kids become show more perseverance? So what the Continua really allows us to do are these 3 big things, and really centered around one central idea of responsive teaching. We want to meet the needs of kids, and the kids that you're working with all have very individual needs. And so what it allows us to do is, number 1, identify the strategies that students are using. So we're able to look at the work that they're doing, notice and name that strategy so students can also communicate it to us. We can also look about where that strategy fits within their progression towards proficiency. So once we have that in place, what we can do is also provide students the next step. So here's the next thing that you need to do.
Okay, so thinking about the continuum, we thought that we could relate it to something that most of us are familiar with, if not everybody, was the DRA. This is actually a picture of the back of a junior DRA, pack of wolves. You can see that in the corner. And so what we thought here is that we can see the bolded titles here are actually the strategies that we want the kids to learn, and the look fors in reading. So when we're trying to get kids to move on in their reading progression, we look at what kind of strategies they're using here and how to move them forward. And so if we think about that in relation to the Continua, what is on the Continua are the strategies, the look fors in math. What are the kids doing? What is the notice and naming that the kids are doing?
And if you can just have your Continuas out there, I think everyone has them in the room today, so if you just have them out and you can make quick reference to them.
Again, this is the multiplication and division continuum. Again, these are the strategies that you're looking for and the next steps that students are doing to move them forward in their math thinking.
So the continua are broken into 4 phases of development. So in the earliest stages, when students are learning to work with number, they use strategies called, or a phase called direct modeling and counting. So in this phase, students are going to, in the example of 5 plus 8, they're going to count out 5 of those objects, or 5 fingers, and they're going to count 8 more. And what they will do is they'll combine those groups and they'll count 1 more time. So that's a strategy called counting 3 times.
A lot of times they'll use manipulatives or dots or fingers to sort of find their way to the answer. If you think about it in multiplication, it'd be 3 times 4, counting out 4 objects, pushing them together, and then counting a second group and a third group of 4 objects.
As students become more proficient, the next phase of this strategy is they use their tracking strategy. So, for example, in the same problem, if a student is solving 5 plus 8, what they might do is commute or reverse the numbers and think about it as 8 plus 5, and then count on from 8. So they would do 9, 10, 11, 12, 13 on their other hand.
Okay. Finally, not finally, but the next stage is working with numbers, and this is sort of the largest chunk of the continuum. And in this phase, we see lots of different strategies happening. This is where kids start developing their own reasoning and flexibility with numbers. This is where if they're adding 8 plus 5, they might change the 5 into a 2 and a 3 and add to make a friendly 10, and then 3 more to find 13.
Or in the earlier stages of multiplication, if they're looking at using a doubling strategy, if they're solving 6 times 4, they might double 6 to get 12, and then add 2 more 6s on to get to 24 to give them the 4 groups.
It's also a good point to note that even though this there is a progression of development in this continuum, the students are. It's not linear. Like the kids are using a variety of strategies. They're moving up and down, forward, and sometimes back, depending on what numbers they're given.
So ultimately, when we're talking about proficiency, we're talking about mastery, and we're looking at, do students understand the mathematics that they're using? Beyond simply memorizing the fact, do they understand what's going on? Are they able to communicate their thinking? Can they justify and reason and prove why their solution makes sense? So for example, we're looking for them to be able to do things like, if they know 5 plus 7 is a fact, they also understand that that would be the same as 6 plus 6, or 5 plus 7 is 2 less than 7 plus 7. So really looking at using those flexible strategies, because they're able to use those when they see a situation or the numbers that fit that situation.
Well said, Dean.
So often, when we're looking at this continuum, we see that our thinking is centered around number sense and enumeration, but it's actually, this is a tool that's going to support students across the curriculum and across all strands of mathematics, and we just wanted to provide you some examples here today.
So we thought we would pull a few strategies that are on the continuum and talk about where you might see them in other aspects. And so subitizing, which is the ability to recognize an amount without actually counting it directly. So I'm thinking about the reckon rec at the bottom corner there. Like, are students able to see that each color means 5 and that a whole row is 10 without counting it? We see a lot of times in dice games and on cards, but also the degrees in on a protractor. So we only have the benchmark numbers there. Are they able to see the 5 is in the middle and count down or up from there?
Or we're working in patterning and students are modeling patterns. Do they see groups of 5? Do they see those collections of numbers? And being able to subitize those is going to free up a lot of the kind of the working space and memory, so students can actually get to the math thinking that we're really pushing them to do.
Okay, another strategy we thought we'd use is the 10 times strategy. So we obviously see that in metric conversion charts, that each unit is 10 times greater than the previous unit.
We see this when we're working with base 10 blocks and that foundational understanding in our base 10 system. 10 units equals a rod, 10 rods equals a flat, 10 flats equals a cube. So we're really seeing that these ideas are embedded throughout all the math that we're doing with students.
Okay, let's move on. Another one we are thinking about is partial products, because we see that a lot. We can see that when we are, partial products is sort of, I guess I should explain it. Partial products is when you find part of a product and then another part of a product, and to find the solution, you add it all together.
So an example of that would be on the left-hand side, there's an area model for what 29 by 20 would look like, and what the student has done has broken them down into chunks that make sense to them. So they did 5 times 20 gives me 100, and we did that 5 times, and then we did 40 times 20 to get the rest of that array. So those ideas we see throughout kind of all of the mathematics or multiplication development, but we also see that when we're looking at surface area of nets, that students can compose and decompose shapes into arrays or into rectangles so that they can calculate the area of each of those portions.
Mm-hmm. Okay, so now that we've given you a few different strategies to think about in where you can see them in other strands of math, we thought we would just sort of finish up by talking about what we want you to walk away from this presentation.
So in the end, the 3 big ideas we want you to leave today's session with are that the Continua allows us to identify the strategies that students are using. So often we see students doing things, but if we don't have a name for them, we can't describe them, we can't name them, and students, we're not using common language so that everybody is clear on sort of what we're talking about.
Right, and actually, so the next part after you identify what the student is using, it's thinking about where that is in their progression of using numbers. And so the continuum can kind of help you with that. Are they in the developing stages, sort of middle stages, or are they becoming very proficient in their thinking?
And ultimately what we really want to see students do is move towards more sophisticated strategies. What we often see is that students find a strategy that they're very comfortable with and they trust, and they continue to stick with that strategy even though it might not be the most efficient or the most accurate. So really what we're doing is we're scaffolding the next strategy that makes sense for that student. So we're really trying to be responsive to the needs of each of your students.
And I just wanted to add in there that if you notice that some of your kids are still counting rhythmically, and maybe they're in the upper junior grades, and we know that they need to move on, moving them on to the standard algorithm or other methods that you see near the end in the proficiency section, we can see that they need to develop some other skills before they get there. And it might not be 1 year, it might not be 2 years, but if they go from counting rhythmically to skip counting and then maybe to doubling, that is a win in my eyes.
Absolutely.
So in closing,
just like to thank Kate and team for helping us to understand the Continua a little bit deeper and offer it out to you. So if you have any questions you'd like to ask us, we'd like some questions and we will answer them right now.
It says ask 3 questions. That's sort of 3 questions overall, not per school.
Just 3 questions, please. We want to get you guys off to lunch.
And crickets.
You were that good.
Crickets. Crickets.
I see we've been very thorough today. What we would really appreciate, we realize that it's just a few minutes before lunch. If you could take a moment to, we only have 3 quick questions. They don't require any typing or words. If you could please provide us a little feedback on today's session, that would be very invaluable to us. This is our first opportunity to be able to do this with everybody, and we hope that it has been productive and informative for each of you.
Okay, so question for you two, how does the Continua match up with grade levels?
Well, you'll notice that there isn't grade levels attached with the Continua, and that is because you will see strategies being used by all students in all grades. And so to actually peg them for one grade is not something that we want to label kids with right away, but using your professional judgment, you know what needs to be done to move kids forward.
And also, this Continua is that as numbers change, students will move sort of up and down those strategies. So, for example, if we move to working with decimal numbers or fractions, students are going to apply the same ideas, but they might move they might change their strategies to maybe something earlier. Or
I'm just thinking of like fraction tiles. When you first introduce fractions, you get the fraction tiles out or whatever other manipulative you have. That's going back to the direct modeling, right? And that's one of the first sort of columns working with numbers, the direct modeling section. So there isn't really a grade associated with it.
Great question, Errol wrote. Can you scroll back to that question?
Mm-hmm.
Errol wrote, so what happens when you have a class that is all over the Continua, and what is the best way to meet them where they are at?
So the next step in the where to next for those of you that are wondering that's where we're looking at using those math games and the activities that allow us to meet with students in small groups. So what you'll be able to do by using the Continua is you'll be able to cluster students by common need, and they'll be able to work in small groups with those, maybe while other students are playing math games that are appropriate to their progress on that Continua.
So the games are a great idea, and I also share with teachers that number talks in small groups is a great way to move kids along the Continua, because if you're doing number talks, you're seeing the same strategies from the same students all the time. And so it's a great way to group kids and meet with them at the back table, in partners or triads, and go through some new strategies with them so they get to know them.
Okay, and lastly, our third question was, can we create a checklist for the math continuum like the DRA example?
Good question.
Mm-hmm.
Let us look at that.
Mm-hmm. We do actually have some examples from existing classrooms. The math coach at your school will definitely have some ideas for that. We can share all those kinds of information with you. It's better to do that one-on-one, yes, because it's kind of personal and per school basis, but there's lots of ways that you can do that.
Yeah, just and as a last note, please talk to us, even if we are not working directly in your classroom
or in your school, because we're sort of wrapping up on some schools. Please
connect with us. You can connect with us through our email or text messages or whatever avenue is best for you. We want to be able to support everyone in a way that's unique to you.
Mm-hmm. Yeah.
So thank you for your participation today. We hope you have a wonderful rest of the day. Please go ahead and enjoy your lunches.
Yes. Thanks, everybody.
Have a great day. Bye.
Bye.